In this video, I'm going to go over the different type of electron domain geometries. Let's start with the two electron domain. Okay, so two electron domains, I have two structure that I would like to show you. So one is, so the dots represent the central atom, right? So these represent the terminal atoms. So which one you think is better according to the Vesper theory, that all the electron domain region will need to stay as far as possible from each other? The answer is this one, right? Because these two regions are apart by 180 degrees, right? Versus this one, it's too close to each other, right? So they're gonna repel each other. So this one would be better representation of the two electron domain, which is going to be linear, right? So two electron domain would be linear geometry. Okay. Now when we have three electron domains, okay, so three electron domain, you either can have this structure or this one. Which one is better? Okay, so this one would be better, right? Because if you're looking at the bond angle, this one would be 90 degrees versus this one would be 120, right? So it's way better if you look at it, right? So it's actually bigger, right? So it's way bigger. Okay, so that means in this case, when you have three electron domains, the geometry will not be this one, but it's going to be this one. This one is called trigonoplanar. The reason why it's called trigonoplanar because it looks like a triangle and it's actually flat, it's in plane, right? It's the flat triangle, which what we call trigonoplanar. Okay, so, and the bond angle is 120 degrees. Okay. Next one, when we have four electron domains, okay, so four electron domains, you can either have it like this, right? So flat like this, or you can have it like this. Okay, so which one you think is better? Okay, so the better one would be this one because you need to put everything as far as possible from each other. If you're looking at bond angle here, it's only 90 degrees, right? So 90 degree, also 90 degree as well. However, for this one, if you're looking at it, right, so it's going to be larger than 90 degree, right? So especially this one that you see here is 109.5 in all parts, right? So this is also 109.5 as well. If I flip this over, this is also 109.5 degree. This is also 109.5 degree. So pretty much all the angle that you see here, they are 109.5 degree away from each other. So this is way better than the 90 degree here. So that means in this case, for the four electron domains, okay, you are going to have tetrahedral geometry. So this geometry is called tetrahedral. So how you draw these? Okay, so you are going to start with, it's going to look like a pyramid as the base, right? And then there will be one sticking on top. So this is called this is called tetrahedral. Okay. When you have five electron domains, okay, so you can either have it like this, right? So 4 and then 5, or another possibility would be this one right here, right? So which one would be better? The answer is this one would be better because the base here is only 90 degrees, right? So and this is also 90, so this one is bad because this is 90 degrees, okay? The base here, if you look at it, is also 90 degrees as well. Okay, so it's a lot smaller than this one because if you're looking at this one, the base that you see here, okay, so this is 120 degrees. Okay, 120 degrees, 120 degrees. And if you flip this over right here, right, so this is going to be 90 degrees here. Okay, so it would be 90 degrees right here. So a bit tilt. So this is called trigonal bipyramidal because the base is look like triangle, right? So this is the base. When I flip it, it's like triangle. But if you flip it this way, it looks like a pyramid, right? Pyramid on top, pyramid on the bottom. So two pyramid. So we call trigonal, right? So this is trigonal bipyramidal. Okay, so this is 5 electron domains. 6 electron domains. Okay, so if you try to put them as far as possible from each other, this is the geometry that you are going to get. This is called octahedral. The reason why it's called octahedral because there are 8 faces. So 1, 2, 3, 4, and then another 4 right on the bottom. So total would be 8 faces. Okay, so for each of those, so this is octahedral. Of these are going to be 90 degrees for all angles. okay, or for all angles. So one thing I would like to actually mention about the trigonal bipyramidal, which is 5 electron domain, this one, two position that you will need to know. One is the axial. The axial would be the vertical, right? The two vertical, and equatorial would be on the horizontal. Okay, the bond angle between axial right here to equatorial would be 90 degree, but for between all of those in equatorial would be 120. Okay, so all of these are 120.